morning guys, this is Mr. M from Algebra Lessons. In this video I'm trying to explain, or I'm trying to help you guys with a part of differentiation called parametric differentiation. This is the differentiation, or this is the topic actually explains you about a different phase of functions and how can we differentiate those kind of functions. That means the functions with a parameter. So these functions is actually have the graphs something like a graph like this. So the function is around a parameter. So before I'm explain the functions in detail, let me explain how to find the derivative of those kind of functions. As you know, the derivative means the rate of change. So these kind of parametric functions will help us to find the value of a function at a particular point, or we can figure out how the function will behave at a particular point. So we can discuss that in detail in another video. In this video I'm trying to show you guys how we can find the derivative of a parametric function and how we can generate the equation of parametric differentiation. Okay, so as you know, if I have a function y is equal to f of x, the derivative is usually dy by dx. Okay, so y is the function of x, then derivative is dy by dx. Question comes in a situation when this x and y are not the functions of the dependent and independent variables separately. If we have the x function and the y function separately in terms of another parameter t, say for example x is equal to f of t and y is equal to g of t. We have two functions, x is equal to f of t and y is equal to g of t. So how can we find the derivative of these functions? Interesting question. This is kind of the new thing that we are trying to discuss, and we need to figure out first how we can find the derivative of this kind of function. For that we need to first understand we have a formula, or we have a method to find the derivative of this function. I can give that formula in advance. Dy by dx is equal to dy by dt over dx by dt. This is actually the formula. But when you are studying something, you need to know how or why this formula. That is very important. The why question. Okay, so you have to ask yourself that why question always if you are studying some kind of a concept or something like that. That is very important. So I am going to answer that why part of this parametric differentiation. Usually as you studied in your previous lessons, or the topic called first principle in differentiation, you are actually familiar with the increment called delta x and delta y. I'm pretty sure you are actually familiar with this. So how can we rewrite this x and y by adding this increment? Okay, So the x function will be x plus delta x, and y function will be y plus delta y. So what is the difference, or what is the change we can make on the other side of the equation? We have x is equal to f of t here. So when I'm adding an increment, of delta x on the left side, we should have another kind of an increment on the right side too. So let it be f of t plus delta t, and here this is g of t plus delta t. Interesting. So our equations changed into another form. From this point we can start our proof. Okay, so now we have x plus delta x and y plus delta y. From this point we can figure out what is delta x and delta y. So consider this as equation 1 and this as equation 2. So from equation 1, delta x is equal to f of t plus delta t minus x, and here from equation 2, delta y is equal to g of t plus delta t minus y. We know what is x and y, so this is f of t plus delta t minus what is x? X is f of t, and here delta y is equal to g of t plus delta t minus y is g of t. Okay, that's great. So we have delta x and delta y. Interesting. Okay, we started from x and y. Now we have delta x and delta y. Okay, we can proceed from this point. We are actually trying to figure out what is dy by dx. As I told you before, dy by dx is the rate of change, okay, or the gradient or the slope of that particular curve at a particular point. Okay, so keep that idea in mind. We are actually trying to figure out the slope of this curve or this function. Okay, so we can first find the change in y over change in x on increments, that is delta y over delta x. Delta y over delta x. We know what is delta y. Delta y is g of t plus delta t minus g of t over delta x is f of t plus delta t minus f of t. F of t. Okay, now I'm going to divide the numerator and denominator with a delta t. So what will happen? Then it will be g of t plus delta t minus g of t over delta t, okay, divided by f of t plus delta t minus f of t. So we can rewrite that as that division like this, divided by f of t plus delta t minus f of t over delta t. Okay, I just write that statement in a line. Okay, and now at this point we can use our previous knowledge of limits. Okay, here we have a delta t is affecting the whole function. So when delta, we have delta, this is delta y over delta x. So just let me rewrite that. Delta y over delta x is equal to g of t plus delta t minus g of t over delta t divided by f of t plus delta t minus f of t over delta t. Okay, now we are actually going to apply our previous knowledge of limits here on the right side, if you are looking on the function on the right side, you can see that delta t is the decision maker. Okay, with respect to delta t, the whole function will change. So as we are actually approaching the problem of limits with, as delta t tends to 0, what will happen to the remaining parts? As delta t tends to 0, as delta t tends to 0, what will happen to delta x and delta y? As delta t tends to 0, what will happen is delta x tends to 0 and delta y will also tends to 0. Okay, because delta t tends to 0 means this is 0, this is 0, this will become 0. That means delta y and delta x tends to 0. So when we are applying the same limit here, okay, so as limit delta x tends to 0, delta y by delta x equal to, because delta x is the decision maker on the left side, that is why we chose as delta x tends to 0. On the right side, the decision maker is delta t, so we will choose the limit for that one. Limit delta t tends to 0, g of t plus delta t minus g of t over delta t, see that function, divided by limit delta t tends to 0, f of t plus delta t minus f of t over delta t. So that is the statement after applying limit. And from the first principle itself, you know that the right side is, this is f of x plus delta x minus f of x divided by delta x. From the first principle of differentiation, you know that that is f dash x. Okay, and this is equal to g dash, from that knowledge, this is g dash t divided by this is f dash t. Okay, so limit delta x tends to 0, delta y by delta x, what is that? That is dy by dx. So this is dy by dx. So dy by dx is equal to g dash t divided by f dash t. Oh, okay, that is interesting. Okay, so this is equal to dy by dt, because g dash t, g is the function of y and f is the function of x. So this is dy by dt divided by f is the function of x, so dx by dt. Okay, so from this we can conclude our equation like this: dy by dx is equal to dy by dt over dx by dt. This is the way we are getting the answer or the solution or the formula. We are generating the formula for parametric differentiation. I hope this explains your thoughts, or I hope this answers your question how I am getting this equation for a parametric differentiation. If you really wish to get more videos on parametric differentiation and the related topics, please like this video, share this video and subscribe my channel. Thank you very much for watching this. Don't forget to press the bell icon. Thank you once again.